Okay, good morning, my dear students. Hope all of you are fit and fine, healthy. Okay, the topic for the day is dispersion, standard deviation. Next chapter or unit, dispersion. In dispersion, we have standard deviation. Few more topics were there, but this time CBSE has removed. So only one topic is there, that is standard deviation, and you have to calculate standard deviation in absolute and in a relative terms. Okay. So before it, let me brief about the dispersion. But the definition of the dispersion. So dispersion is a measure of the variation of items. It measures the variation in the items. When there is a variation in the items, let you have calculated mean. Okay. See in the earlier topics, central tendency. So in that central tendency, we learned about mean, mode, median. Like mean. So mean, then I will give you one example. Let your average marks. I'm talking about the central tendency. Your average marks, for example, 92%. It does not mean that you obtained 92 marks in each subject. Let you opted 5 subjects. Do you mean that you obtained 92 marks in each subject? Sometimes maybe more than 92 in one subject, another maybe less than 92. Okay, what your average marks or mean marks? Mean marks 92. Now what is the variation now? Variation from the mean marks. So that is the mean. Now is it clear about the dispersion? Now dispersion, what does it does is measure the dispersion, measure the variation of the items. It measures the variation. Now variation from 92 to let 88 or 95. Okay, to rest of the values. Okay, rest of the values. So that variation we had to measure in the dispersion. So next, what are the objectives of dispersion? What are the objectives of dispersion? First objective is to know the variation of the different values of the item from the average. Now different items, I gave the example that your average marks 92%. Now 92%, and you might have scored more than 92 in A subject or B subject, or less than 92 in another subjects. So this means different values of the item, variation of the different values that can be measured in the dispersion. Second point, that is related to know about the composition of series or the dispersal of the values either sides of the central tendency. Either side of the central tendency, 92 is average marks. I said you might have scored more than 92, let 99 is highest score and 85 is the lowest. So either side means 99 highest and 85 is the lowest, whereas your mean marks 92. So either side means composition of series or dispersal of values on either sides of the central tendency can be measured through dispersion. Third point is to know the range of values, means difference between highest and the lowest value. Difference between highest and lowest. Highest is 99 and lowest is 85. So this way I am explaining the given example only. Just I gave one example. Your mean marks 92%, mean marks, average marks, but highest is 99, lowest is 85. So this person measure the range of highest to lowest. Fourth point of the objectives of this dispersion, to compare the disparity between two or more series in other or find the degrees of variation. it also measures the degree of variation. Degree of variation in the relative methods. We have two methods are there. One is absolute standard deviation, another is relative dispersion or relative we can standard deviation. So in the relative we find out the answer in the degrees or in the percentage, whereas in the absolute we measure the number only. Last point or last objective of the dispersion is to know whether the central tendency truly represent the series or not, whether the given means the value really represent the entire series or not. Okay, whether the central tendency truly represent that central tendency like 92 marks. So 92 marks truly represent the whole series, truly represent about the other about the 5 subjects or not. So these are the objectives of the dispersion. First, know the variation between relative to the measure, to know the variation variation in the items. Second, composition of the series. Dispersal means either side. Measure the dispersal of either side means highest to lowest. Lowest in the means in which 92 is the central, either side 99 is the highest and 85 is the lowest in the given example. So either side of that central tendency, that value can be measured. Third point I told you, it also measures the range between highest and lowest number. Highest and lowest number can be measured through dispersion. Okay, so it also gives some it also tell or teach us about the degree of variations. Degree of variation can be measured in the dispersion. Last point, that is, it also let us know whether central tendency is truly representing the series or not. So this is about objective of the central tendency. Objective of the central tendency in the central objective of the dispersion. Sorry, dispersion. Objective of the dispersion. So in this dispersion, we will study about one topic that is standard deviation. Standard deviation. So standard deviation, absolute standard deviation and relative standard deviation. So we will study about both the formats, absolute and relative standard deviation. Relative and absolute standard deviation. Okay. Now the meaning of standard deviation. Okay. We have different methods. First method to calculate, this is your standard deviation. Standard deviation, this is the topic for the day we did. Standard deviation. And first method, this is your actual mean method. Actual mean method. So standard deviation, or we also represent by sigma. Okay. You can write SD. SD means standard deviation or sigma, one of the same thing. So in case of actual mean method, the formula is under root summation x square upon n. This is a small x between. Small x square. Is it visible or not? Visible or not this one? If not visible, then let me write. Visible? Small x square. Small x means deviation. Deviation method. I wrote here also small x. So small x is equal to x value of the series minus mean. Minus mean. Okay? Actual mean. So, or another format of the formula, under root summation bracket start x minus x bar. X minus x bar means mean, bracket close whole square divided by n. So x minus x bar X means value of the series, and X bar means mean value of the series, So the difference of X values of the X series and mean value of the series, what we have to do? Square of that divided by n, number of observations, so whole under root. Now I am going to read the formula of standard deviation. So standard deviation is the square root. Okay, standard deviation is the square root of arithmetic mean of square of all deviations. So this is square of all deviation. I wrote here x square, or here we can write x minus x bar whole square. Are you getting? So formula is from the definition only. Definition itself making the formula. So I'm going to repeat again. Standard deviation is a square root of the arithmetic mean of square of all deviations. Square of all the deviation being measured from the arithmetic mean of the item, and deviation is measured from arithmetic mean. This is a arithmetic mean. Deviation is measured from the arithmetic mean, means x is a value like 12, 8, 17, 13, 15, 9 and 18. So minus actual mean 11. Are you getting? So formula is under root summation of x square, deviation square of the deviation. This you can also call it square of the deviation divided by number of observations. So in the given question, marks are given 12, 8, 17, 13, 15, 9, 18, 11, 6 and 1. These are the marks obtained by the students in the given class test. So calculate standard deviation by actual mean method. So here marks. So do the sum of marks. So total marks are 110. How many are there? Total marks are 110. So total marks 110. Now after this, what we have to do? Number of observations, because here divided by n stand for number of observations. So number of observations, now you have to calculate. You can give serial number. So this is an individual series. So in individual series, you can give serial number yourself, or you calculate or else you can calculate total number of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can say 10 observations are there, or there are 10 students. Those who have taken the class test and their marks are 12, 8, 17 and so on. These are their marks. So you can also write, if you want, serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to 10, means number of observations are 10, or else these are the marks 12, 8, 17, 13, 15 and so on. So these are the marks So marks obtained by how many students? So number of students are 10, those who have taken the class test. So number of observations 10. Number of observations 10. Okay, now is it more clear? Yeah, it is more clear now. So number of observations are 10. Got it? Now x square or x minus x bar. X minus x bar. So this x bar means mean. Mean. This is your mean weightage. Now how to calculate the value of mean? This you learned in the central tendency. So mean marks. Mean is equal to summation x means sum of observations. Sum x is 110. Number of observations. Okay. The sum of total marks. So sum of total marks 110. 110. So total marks obtained by all the students. If you do sum, then you will be getting 110. So 110 sum x, summation of the total marks. Now divided by n. N is number of observations. So here we have 10 students. So 110 upon 10 is equal to 11. So mean marks 11. So I wrote here x bar. X bar means mean marks. Mean marks are 11. Mean marks are 11. Now next step, calculation of deviation. Now there is a deviation. See, mean marks are 11. Mean marks are 11, but here we have 17. Highest and lowest is 1. So there is a variation. What I said? Mean marks are 11. But see the highest number 18. Highest number 18 and lowest is 1. So there is a deviation. There is a difference. Deviation. So that deviation we have to calculate now. Okay. So deviation. So I wrote here x. Small x stand for deviation. Small x stand for deviation. And x means number of observations minus mean. Minus mean. Mean is 11. I calculated here the value of mean. So mean marks are 11 weighted. Mean marks are 11 and this is nothing but your marks. Your marks. So let us calculate the value of mean, deviation. Deviation. Understood the meaning of deviation weighted? Deviation means your mean marks. I am coming back again. Mean marks sum x upon n. So 110 upon 10, 11. Mean marks, average marks, your average marks 11. Okay. 11 is the average marks. But if you go through the numbers, data, you will observe highest is 18, lowest is 1. Highest 18 marks, lowest 1 mark. So now the deviation from 11 marks. Calculate the deviation from 11 marks. 11 means mean marks, deviation from the mean marks. So 12, 8, 17, 13, 15, 9, 18, 11, 6. And here 1. Okay. Now minus 11, 11, 11. Why 11? Because here mean marks. Mean marks are 11. I wrote here also. Okay. Separate corner is there for the mean marks. So mean marks I wrote here 11. Okay. So 12 minus 11, 1. 8 minus 11, minus 3. Okay. 17 minus 11, 6. 13 minus 11, 2. And so on. and so on. 15 minus 11, 4, 9 minus 11, minus 2, 18 minus 11, 7, 11 minus 11, 0, 6 minus 11, minus 5. So 1 minus 11, minus 10. So the sum x is 0, means total plus items and minus are equal. Okay. Now next step is square of deviation. Square of deviation. Here x square means square of deviation. Small x, this is a small x means deviation. Now square of the deviation. Square of the deviation. Is any doubt up to this point? Is there any doubt to anybody? If you have any doubt, you are most welcome with it. No? In case of any doubt, you are most welcome. Any query? No? Otherwise, I will proceed. Now, square of 1, here 1, square of 1, 1. Minus 3, 3 3s are 9. 6, square of 6, 6 6 are 46. And square of 2, 4, square of 4, 16. Minus 2, 4. And 7, square of 7, 7 7s are 49. And 0 0 and minus 5, 25. And 10 minus 10, 100. 100. So summation of square of the deviation. Summation of square of deviation. Summation here. Summation of square of deviation. Square of deviation. And this is x minus x bar whole square, means square of the deviation. One of the same thing. One of the same thing. Now the total or summation of 1, 9, 36, 4, 16, 4, 49, 25 and 100 would be equal to 20. Here 1, 9, 10, 20, 30, then 39, 39 and 5, 4. 7, 8, 12, 13, 14. And 1 plus 1, 2. 1 plus 1, 2. So 244. 244. So square of deviation. Sum of square of deviation is 244. 244. Now place these values. I wrote here standard deviation. Standard deviation or sigma, that is equal to summation x square under root summation x square upon n. So summation x square or deviation of the square, sum of deviation of the square is 244 divided by number of observations. Number of observations are 10. Number of observations are 10. So 244 divided by 10 is equal to 24 point under root 24.4. So the answer is standard deviation 4.94. 4.94. See 24.4 around 25. So 5 5s are 25. 5 5s are 25 and 4.94 is near to the 5. So this way we can calculate the value of standard deviation. Now standard deviation itself absolute number. This is absolute number. Now coefficient of standard deviation. Coefficient of standard deviation is relative value. Now the formula to find out the coefficient of standard deviation upon mean. Standard deviation upon mean. So standard deviation is 4.94, 4.94, 4.94 divided by mean. So mean, average marks, mean marks 11. So when you will divide 4.94 by 11, you will be getting 0.45. So here I wrote CSD. C stands for coefficient. C stands for coefficient. Coefficient of standard deviation. So answer is 0.45. And the value of standard deviation, here the value of standard deviation 4.94, and coefficient of standard deviation. Coefficient of standard deviation 0.45. So this is about the formula. Actual mean method. Actual mean method. So this way we have to find out the value of standard deviation. Standard deviation. So when I taught you about the objective of dispersion, then fourth point I taught you to compare the disparity between two or more series in order to find out the degree of variation. To find out the degree of variation. So degree of variation we can find with the help of relative method. Standard deviation itself, this is 4.94 is an absolute number. This absolute standard deviation, and this is relative standard deviation. Relative is also known as coefficient of standard deviation. Coefficient of standard deviation. So this is about the actual mean method. Actual mean method. So in the actual mean, you have to find out the actual value of mean. Don't assume mean. We don't have to assume mean marks. Okay. Here we have to find out the actual value of mean. Which is why I wrote here. This is the meaning of actual mean method. Actual mean method. So in case of any query, you are most welcome. Meanwhile, you can copy the answer with it. In case of query, you are most welcome. Otherwise, I am going to over it. Okay, I will be giving you one question, bete. I am giving you one question. Calculate standard deviation by actual mean method for the following data. Data you will be getting through WhatsApp, bete. Something positive. Yeah.